In this video, I'm going to show you how to manually configure router ID. So the purpose of router ID is to uniquely identify a router. So what happens with OSPF is LSAs are exchanged between routers. That includes the routing information, as well as area ID. And from that, OSPF will build a database for each area with all known links, or inter-area and external routes. And from that, the router will derive a OSPF routing table. That's based on preferred routes. So the default behavior of a Cisco device is to assign the highest physical interface as router ID if there's no loopback interface or manually configured router ID. If I configure a router ID, for example, that'll take precedence over loopback address or any physical interfaces, since that's the preference. So with this topology here, I have no router ID manually configured on any router. So with that, the next preference would be the highest loopback interface on that device. And I don't have any loopback interfaces configured on any of these devices. So what it'll do is it'll pick the highest IP address assigned to a physical interface that's enabled. And that's what's currently enabled here for this lab. So I'll go to R1. If I do show IP OSPF neighbor, this neighbor ID represents the router ID. These are all physical interfaces. So for example, 192.168.3.2, that has full adjacency with this R1. So where is 192.168.3.2? Well, there's the 3 subnet there. So notice on R2, gig 001, that's 192.168.3.2. That's the highest physical interface on R2. So R1 has an adjacency with R2, and this interface is the router ID R2 is sending to R1. Then there's 192.168.3.1. That would have to be this R3 gig 001, because this is the 192.168.3 subnet. So R3 is sending 192.168.3.1 is its router ID to R1. And the 172.16.1.1, that's the remote router. There's only a single physical interface. There's no loopback interface. So that's the router ID for remote. I'm going to manually assign router IDs. For R1, it's going to be 1.1.1.1. And R2 will be 2.2.2.2. And R3 will be 3.3.3.3. And what I'm going to do also on the remote to show you how this router ID is selected based on first manually configured router ID, then highest loopback interface address, the highest IP address on a physical interfaces. And that's the order of preference. What I'm going to do on the remote is actually assign a loopback address on the remote just to show you that the loopback is selected over a physical interface. All these routers have an OSPF global configuration. So router OSPF 1, router ID 1111. Notice there's a hyphen there. After I'm finished, I'm going to have to clear IP OSPF process to rebuild the database based on the new router ID. So I'll go to R2. And router 3. That's all there is to that. Now, since on remote I'm going to use the loopback as the router ID, I need to configure the loopback address. So the IP address is 172.16.2551. This is a /32. Then I'll just use the interface command. So I'm directly connected to R1. IP OSPF1 error 0. And that's all there is to that. And I'll just save the configuration. So now the command on each router, clear IP OSPF process. Say yes to this. It'll reset the adjacencies as well. So I run show IP OSPF neighbor on all the routers after this reset. You notice here now the neighbor ID is 1111. This is on remote, and this is to R1. R1 has R2 and R3. There it is there. 2 and 3. And the loop back of the remote router is 172.16.2551. So that's working correctly. R2, there's 1111, that's R1. And the bottom one is R3. And R3 is showing the router ID of R1 and R2. So that verifies the router ID is working correctly. There's two other commands you can use to verify router ID as well. And that's show IP OSPF interface gig 000. You notice process ID 1, router ID 1111. And the other command is show IP protocols. So to look for the OSPF section, there it is there at the top. Router ID 1111. Also gives you the network addresses that are being advertised. Number of errors is just one. It's just one normal. And that's error 0. And that concludes the video.